Hello everyone. Today, the first topic of our presentation is mastering the game of Go with deep neural networks and research. Can you move on the slides, Prapurna? Yeah, the next one. Yeah. Basically, the game of the Go is like we present. There are two players. It is actually an abstract strategy board game in which two players. The main aim of this game is to like occupy more area than the opposing player. Whoever occupies more area in the board itself, those wins the game. We present a novel approach to computer Go that employs value networks to evaluate the board positions and policy networks to select moves. In this field of computer science, the AlphaGo game employs neural algorithms to train various networks. The unique combination of this supervised learning from human expert games and reinforced learning from self-play games is used to train these deep neural networks. But a new search algorithm that combines Monte Carlo situation and the value and policy networks is presented. Using this search algorithm, our program AlphaGo defeated the human European Go champion by 5 games to 0 and has accurately 99.8 winning rate against these other Go games. Yeah, the next slide, please. Yeah, here we can discuss about the four policies. We have the first one is supervised learning policy. This policy's main aim is to predict the expert's next move. Here, you can see I have mentioned that three percentages where when we give input features, the accuracy is 57%, and when using board positions, it is 55.8. And in rollout policy, the accuracy is like 24. In supervising policy, the data is trained using the stochastic gradient in the presence of human expert. To increase the probability of switching the data between the convolution layers and rectify non-linearities in its initial state of board game. The output movement is received through the softmax layer. It also shows that at 24.2% accuracy when using the rollout policy differs from an unsupervised policy in which data is trained because based on factors such as distance and other factors. The expert move is to predict by supervised learning policy. They trained a 13-year policy network called SL policy network with a large number of positions available on KGS Go servers. Yeah. The next policy is like reinforced learning policy. You can call it as RL network. It is basically similar to SL network, supervised learning policy network. Its goal is to use policy gradient reinforcement to improve the policy gradient. It uses the previously said stochastic gradient for weight updating. Reinforced learning policy is a policy network that is identical to supervised learning and is built based on the supervised policies. As a result, it allows the system to improve its levels without involving human experts and aids in policy improvement. As a result, Go program won over 80% of the games. Yeah, the next slide. Yeah, here we can see the figure describes the strength and accuracy of these policies over the network. The figure A describes the policy network, and in figure B, you can see the value networks and rollout network using different policies. During the training, the strength and accuracy of the policy and value networks were assessed in policy network with 128 to 56 and 192 layers being evaluated. We also put Pachi, the strongest open source program that is called to test, and it is sophisticated Monte Carlo as such approach that executes over 100k simulations per move and is ranked at 2 amateur Dan on KDS. The RL policy network defeated Apache program 80%, 85% of the time with no success at all. The winning rate of a Go program using this policy network can be seen in the first graph above, which is the A part. In the second graph, different policies are used to compare. Yeah, the third one we can see is like reinforced learning of value networks. A According to the current stage of the board, the value network predicts the possible winning rate of the winning rate possibility. The main aim of this policy network is to predict the possibility of the win. Here we can use mean square error for network training in this network. The value network memorized the game outcome rather than generalizing to new positions and find on KGS dataset in this way. With a minimum MSC of 0.37 on the test set compared to 0.19 on the training set. Overfitting is caused by the simple approach of predicting game outcomes from data consisting of complete games. The issue is that successive positions are highly correlated with only one stop separating them. In the next slide, please. Yeah, here is the approach of Monte Carlo research in the AlphaGo program. You can see these are all the sections where an expansion and evolution and backup. We can see how different such trees approaches such as selection, expansion, and evolution and backup are carried out. After many simulations, we arrive at the best solution in this Monte Carlo search. The optimal value aids the player in selecting the next move. Learning of convolution networks won 11% of the games against Fudge. This is the final result. We can see evaluating the playing strengths of AlphaGo. In order to access AlphaGo strength, researchers held a tournament against another Go program. In addition, the games was played between 4 handicap stones with an opponent having free movement, but the outcome was always in favor of AlphaGo, the crazy stones. The distributed version of AlphaGo, on the other hand, was even more powerful than the other program. Our next topic will be continued by my teammate, Saiti.
Hi everyone. Yeah, the next topic is like mastering the game of Go without the human knowledge. Yeah, Prabhuna, if you can move on to next slide. Yeah, so the progress towards the AI has been made using the supervised learning systems. So these supervised learning systems are trained to replicate the decisions of the human experts. So AlphaGo is the first program to achieve this superhuman performance in the Go, where it first published version is AlphaGo Fan. And there is one more version which is called as AlphaGo Lee, which defeated the Lee Sedol, who is the winner of 18th international titles in 2016. So AlphaGo Fan, it uses two deep neural networks, which are called as policy network and value network. So policy network, it outputs more probabilities. Value network outputs a position evaluation. And policy network was initially trained by supervised learning to predict the human expert moves. AlphaGo Zero, it differs from AlphaGo Fan and AlphaGo Lee as it is solely trained by self-played reinforcement learning. AlphaGo Zero uses black and white stones from the board as input features, and AlphaGo Zero uses single evaluation neural network to evaluate the moves and prediction. Moving on to next slide. How reinforcement learning is implemented in AlphaGo. So reinforcement learning method, it uses a deep neural network that takes the raw board representation of position, which takes the history as input and output both the moves, probabilities and its values. Neural network in AlphaGo Zero is trained from gains of self-play by a novel reinforcement algorithm. This novel reinforcement algorithm, in each position S, this MCTS search is executed and it is guided by the neural network. MCTS search is viewed as a powerful policy improvement operator for this neural network AlphaGo Zero training. So the main idea of this reinforcement learning algorithm is to use the search operators repeatedly in a policy iteration procedure. So neural network, it combines both the roles of policy network as well as value network into a single architecture. Yeah, if you see here, the reinforcement learning in AlphaGo Zero, we are seeing like both the self-play as well as neural network training. So in the self-play, a program will play from S1 to ST against itself, and the MCTS search is executed using the latest neural structure in each position. And at the terminal position, ST is scored according to the rules of the game winner, that is Z. So coming to this neural network training in the AlphaGo Zero, which is the figure B we are seeing. So the neural network takes the raw board position ST as its input, and it passes it through many convolutional layers, which is a parameter beta, which is, the beta we are seeing there, and the outputs of both a vector is pt, which represents a probability distribution over the moves, and a scalar value is vt, that represents the probability of the current layer winning in the position st. Moving on to the next slide. So the next thing is empirical analysis of the AlphaGo training. So as we apply the reinforcement learning pipeline to train the program of AlphaGo Zero, the training started from completely random behavior and contributed without any human intervention. For approximately 3 days, this empirical analysis is performed. So during this training, 4.9 million games of self-play were generated using 1600 simulations, and each MCTS search was performed, which means approximately 0.4 seconds of thinking is given per each move in this empirical analysis. Yeah, moving on to next slide. Here we can see the various pictures where it shows the performance of AlphaGo Zero during the self-play reinforcement, and also the prediction accuracy of all the performance moves, and also the mean square error of the professional game. So if you see here, the AlphaGo Zero outperformed the AlphaGo Lee after just 36 hours. And in comparison, AlphaGo Lee was trained over several months. And after 72 hours, we evaluated like the AlphaGo Zero was against the version of AlphaGo Lee that defeated the C Little under the same 2-hour controls and match conditions. So the mean squared error of the professional game outcomes were also displayed in this picture, which depicts the MSCs of each outcome in the game. Moving on to the next slide. Here we can see comparison of the neural network architectures, like how the neural network architectures are compared. So the comparison of neural network architecture using either the separate or combined policies and also the dual networks. So the combination of the dual resistance and also the SCP convention correspond to the neural network architectures which are used in AlphaGo Zero as well as AlphaGo Fan and so on. So each network was trained on a fixed data set, which is generated by the previous run of AlphaGo Zero. So each trained network was combined in the figure A. We can see each trained network was combined with AlphaGo Zero search to obtain a different player. So the LO ratings were computed from evaluation the games between these different players using 5 seconds of thinking per each move. So the prediction accuracy of the human professional moves were defined in picture B. And coming to the C, we can see the MSC, which is like the mean square error of the human professional game outcomes of the each network architecture was defined accordingly with the moves. So the next part of the presentation will be continued by my teammate Prapurna.
Here we go to the final performance of AlphaGo Zero, and all programs were given 5 of thinking of each time of the move in your evaluation. And AlphaGo Zero and AlphaGo Master were both run on a single computer with 4 TPUs. And we also include a player who is only based on the AlphaGo Zero raw neutral networks. So this player nearly choose the move is the highest probability, and which without the use of MCTS, this selects the move of the highest probability P on the bioscale of 25, and the 200-point difference equals to as a 75% of chance of victory. And here we go through the methods of the reinforcement learnings. And reinforcement learning is using a basic Monte Carlo search classification based on the reinforcement learning of 37 improves policy. So for each action of that reinforcement learning, and multiple rollouts are performed, which takes the highest mean value of the among the uh, conducted survey. For example, the other actions serve as a negative training, and the trained action serves as to be the positive or negative. Then it is used to be subsequent rollouts. And for when zero is used, this can be seen as a procedure to the policy. component of AlphaGo 0's training process. And we have 4 forms of AlphaGo 0 forms. First one is AlphaGo fan, and second one is AlphaGo Lee, and third one is AlphaGo master, and fourth one is AlphaGo 0. Among this, we have taken the 3 unmistakable adaptations of AlphaGo, and first one is AlphaGo fan is recently its distributed program of 12, and this program was circulated over many machines utilizing the 176 GPUs, and AlphaGo Lee is this is used in 48 TPUs and opposed to use in the GPUs, where AlphaGo fan is used for the GPUs, and AlphaGo master is used for MCTS, and AlphaGo 0 is used for 4 TPUs. Here is the conclusion part. In this conclusion part, we are from the 2 papers, we have compared the training of the human expert data. A pure reinforcement learning strategy takes only a few more hours to train and produces subsequently greater asymptotic performance. AlphaGo 0 performed the highest, more powerful prior versions of AlphaGo, and AlphaGo have 4 versions of it, and which are trained using the human data using handicrafted characteristics by a significant margin. And these are the references of those 2 papers, and we have taken from these references. Finally, thank you.
Thank you.